Pre-cal. Today we're going to look at how to simplify problems in the lowest radical form. These problems are going to be a little step above what we were looking at last time. Make sure you still have your perfect square and perfect cube list handy, and that'll make the problems go much faster. Question number 1, to review what we looked at in the last class. The index number is 2 when you do not see a number outside. The radicand is 54, x to the 4th, y to the 7th, and z to the 3rd. Your first task is to see if 54 is a perfect square. Since 7 times 7 is 49 and 8 times 8 is 64, and 54 is not in that list, there is no whole number answer to the square root of 54. After you make that call, then you are to find the highest perfect square number that will nicely divide into 54. So numbers like 4, 9, 16, 25, 36, and so on. In this particular problem, 54, the highest perfect square that will divide into it, would be 9. So you're going to write 54 as 9 times 6. Okay, then you're going to look at the x, and you're going to notice it has a power of 4. Since the index number is 2, and 4 can be divided by 2 nicely, for right now, you're going to leave it alone. You're not going to have to rewrite x to the 4th. You can move to the y next. On the y to the 7th, we cannot divide 7 by 2 and it be a nice number. So right now would be a good time to show a different way to write y to the 7th. Y to the 7th can be written as y to the 1st times y to the 6th, y to the 2nd times y to the 5th, y to the 3rd times y to the 4th. There are all kinds of options, but the best option is the one that's going to be closest to 7, and you're able to simplify, divide it by 2, and get a nice whole number. So I'm going to choose to write y to the 6th times y to the 1st. Then you're going to move forward to the z's. The z is to the 3rd power. 3 divided by 2 is not a nice whole number. So you're then going to write z, break it up into factors, and we're going to choose to write z to the 2nd times z to the 1st. And again, when you're writing them as factors, just remember from Algebra 1 and 2, when you are putting the time signs in between, the product rule says you're to add powers, and so that definitely is equal to the step above. Then your job is to go through, after you've written all of the factors out, and I like to underline the pieces that are actually going to simplify in the next step. I can do the square root of 9 in a second. I can definitely do the square root of x to the 4th. I can do y to the 6th, and I can do z to the 2nd. Okay, so your answer would then be the square root of 9, which is 3, the square root of x to the 4th, which is x to the 2nd, the square root of y to the 6th, which becomes y to the 6th divided by 2, and that's going to be y to the 3rd. And then you're going to do the square root of z to the 2nd, and that's just going to be z. So all the pieces I've underlined in green have simplified and come out in front of the square root. And then all the pieces that are left, like the 6, for example, that cannot be simplified any further into a perfect square. The y and the z, all of these are going to stay underneath the radical. Okay, so that would be your final answer. That's called simplified radical form. Now, I know it may not look like it's simplified because there's a lot going on there, but that is the best simplified radical answer. Please make sure when you are doing radical form, you never give me decimals. Okay, let's try number 2. On question example 2, I have a cube root. I can see that I've got that index of 3, and my right hand is 54, a to the 9th, b to the 13th. Okay, so now my brain has to switch to perfect cubes. Perfect cubes are 1, 8, 27, 4 times 4 times 4, 64. So I'm thinking 54 definitely is not in that list, so it's not going to work nicely. So I'm going to have to rewrite 54 as factors, basically. The highest perfect cube that will divide into 54 would be 27. So we're going to write 54 is the same thing as 27 times 2. Then you're going to look at your A. Power is 9. If you divide 9 by 3, it does give you a nice number. I don't want you to answer it right now yet, because in the second step, you're just basically showing me what can be written as factors. So you're going to just drop the a to the 9th down, and we'll simplify that in the next step in just a minute. And then you're going to move to the b, and on the b, you're going to notice the power is 13. If the power is 13 and you divide it by 3, that's not a nice whole number. And so b to the 13th needs to be written a different way. What your whole goal is to get as close as you can to the 13th, okay? And that would be 12. And then you ask yourself, well, can I divide 12 by 3? If I can, then that would be a good option. So we are going to write b to the 13th as b to the 12th times b to the 1st. Okay, and so then you're going to go through and you're going to underline all the pieces that you can do the cube root of. I know I'm going to be able to simplify the cube root of 27. I definitely can do this piece, and I can do this piece. And so in the next step, you're going to simplify what you can. The cube root of 27 is going to be 3. 3 times 3 times 3 is 27. The cube root of a to the 9th is going to be a to the 9 divided by 3, which is going to be 3. The cube root of b to the 12th is going to be b to the 12 divided by 3, and that will be a 4. And then please remember to use your little index number on the inside of that radical symbol. That is a common mistake. Sometimes students forget to write that down. And if you do, then technically it is wrong, because then you're giving me a square root answer. So make sure you don't forget that little number. And then everything I did not underline, I'm just telling the reader this cannot be simplified. These two pieces have to stay underneath the radical. So it would be the cube root of 2b. Okay, so this again is called the simplified radical form. That would be my entire answer. Okay, we're going to move forward and try question 3. Okay, on question 3, this one has an index of 2. You can see that because there's not a number here. So our brains switch back to perfect squares, 4, 9, 16, 25, and so on. Is 60 a perfect square is the question you ask yourself, and the answer to that is no. You then try to find the highest perfect square that will divide into 60. So thinking from the list, I know 4 will divide into 60, 9 does not, 16 does not, 25 does not, 36 is a no, 49 is a no, and then 64 is too big. So the highest one I could find is 4. So I will write 4 times 15. 4 times 15 is 60. I'll look at my P. Power is 6. I definitely can divide 6 by 2 and it'd be a nice whole number. So for right now, again, make sure you just drop it down and we'll answer it in the next step. Then you move to the q and you ask yourself the same question. Can you divide the power by the index and it be a nice whole number? And in this case, it's a no. 15 divided by 2 is not a whole number. So I'm going to get as close as I can to 15 without going over, and that would be 14. And then before you write it down, you're always asking yourself, would I be able to simplify that? 14 divided by 2 does work nicely. So that is kind of the way you need to visualize it in your head, and that will get you to the best answer. So I'm going to write this as q to the 14th times q to the first. And then just like the first two examples, I always like to underline the pieces I'm going to simplify. So I'm definitely going to do the 4, looks like the p to the 6th, and q to the 14th. And so in the next step, I'm going to answer it. The square root of 4 is 2. The square root of p to the 6th is p to the 3rd. The square root of q to the 14th is q to the 14 divided by 2. It's going to be a nice 7. And then I'm going to have the square root left. And then underneath, I'm going to have 15. And then the q. Making sure I didn't leave anything out here. Got all my pieces. That is simplified radical form. Okay, we'll try number 4. In number 4, notice this time the index number is 4. So we have to think about numbers like 1 to the 4th, which is just 1, 2 to the 4th, which is 16, 3 to the 4th, which is 81, and so on. Okay, so you might have to, when the index number gets bigger than 3, this might be a good starting point to make a little list of numbers, like powers, to the side. Okay, so based on what I see right there, obviously 80 is not in the list. 16, though, does go into 80, so I'm going to write 80 as a factor. So I'm going to say 16 times 5. Okay, and then I look at x to the 9th. 9 divided by 4 is not going to be a whole number, so I'm going to have to choose to write x to the 9th as x to the 8th. 8 should work, times x to the 1st. And then I'm going to look at the y to 20th. 20 divided by 4 is going to work nicely, so if it works, you're going to not rewrite it. You're just going to drop it down, and we'll change it in a minute. And then last, z to the 3rd. Now, the power here is less than the index, and so I'm not going to be able to simplify that no matter what, because 3 divided by 4 is already a fraction. So I'm just going to leave it as 3. Nothing else to do there. And then you're going to go back, and you're going to underline all the pieces that work. I can do the 4th root of 16, because it's in this list over here. I can do the 4th root of x to the 8th, and y to the 20th. So only those 3 pieces are going to come outside the radical. So 4th root of 16 is going to be 2. When you can simplify it, it comes outside the radical. The 4th root of x to the 8th is 8 divided by 4, so it's going to be x to the 2nd power. And then, let's see, the 4th root of y to the 20th is y to the 20 divided by 4, and that's just going to be a 5. Okay, and then that's it. And your job is to write down your little index number again. Don't forget that. And your radical symbol. And then anything else that's left underneath has to stay where it is. So 5 is going to stay. X to the 1st is going to stay. And z to the 3rd also has to stay. All right, and so that is your simplified version right there. Okay, so make sure you are looking at the index first and then just referring to the correct set of numbers and trying your best to get it down into the smallest terms you can.